Hey there guys, welcome to the 2.1 video for absolute value transformations. So this is your lesson 2.1. We are starting to get more into depth about each function family. So in this unit, we're going to talk about the absolute value function family. So to begin, we are going to fill out our table so that we can graph our absolute value parent function. Remember, the parent function is the original function. Nothing being changed to it. It starts at 0, 0. No shifts left, no shifts right, no reflections, no compressions, no stretches, just the regular parent function. So first off, for my absolute value parent function, I have an equation of f of x equals absolute value of x. So that's my general equation. So to get my y values, I'm going to plug in my x value here to see what my output is. Now remember, absolute value bars, what they do is something special. Anything inside my absolute value bars will become positive. So if I plug in a negative 2 into my absolute value bars, I get an output of a positive 2. Similarly, I'm going to do the same thing here. I'm going to input a negative 1 into my absolute value bar. My output will be a positive 1. If I input 0, my output is 0. If I input a positive number into my absolute value bars, well, it stays positive. It does not change sign. Everything just becomes positive, and if it's already positive, it's going to stay positive. So then I have plug in a 2, and I'll get a 2 as an output value. So now these are my coordinate points. So I'm going to plot negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Now something that you may notice in your points is that we go 2, 1, 0, and then a 2, 1, 0 here. So we see that our points repeat, and in fact, we see that it happens here. We have a reflection, so we would call this graph symmetrical. In that it kind of is symmetrical, or there's a line of symmetry through the middle, where you kind of imagine it has a reflection of itself about the x-axis. Remember, when you connect points, especially in this case, if we don't specify that we have a restricted domain, then it needs to go all the way, not just at this point, all the way, and arrows mean it keeps going. And if you recall, your absolute value functions have the V shape. So this is my absolute value parent function. Now let's talk about the domain and range of my absolute value parent function. So I'm going to use set notation for my domain and range. So first off, for my domain, I can see that it's going forever to the right, or forever to the left, so towards the negatives, forever towards the positives in the right. If it goes forever in both directions, remember we call this a domain, from negative infinity to infinity. So that's it in interval notation. In interval notation for my range, notice it does go forever upwards because my lines are pointing upwards. However, I have no line pointing downwards. So since it does not go forever in both directions, up and down, this one does not go from negative infinity to infinity. In fact, I have a lowest y value. My lowest y value I can see is right here, and y is 0. So 0 is my lowest, and it goes from 0. Since these arrows are going upwards, they're going towards infinity. Now, infinity can never have a closed bracket. It always has to have a curved bracket. Now, in this case, for the 0, since it is a closed circle, I can be 0. In fact, I see in my table that 0 is a value possible in my function. I will have a square bracket. So this is my domain, and this is my range, from negative infinity to infinity, and from 0 to infinity. Now, this is a nice, handy chart. It's a lot of information, so we'll go back to it. But this is all of your transformations all in one place. So we have vertical transformations. And for my vertical transformations, I can see that I have transformations happening outside of my function. So in our example, if I see a +3 outside of the absolute value bars, that tells me I have a vertical transformation. So vertical transformations are outside of the absolute value bars. And then it will tell me if I have a positive number here, then I have a vertical transformation up 3. Versus if I have negative 3 outside my absolute value bars or outside my function notation, then I'm going to go down 3. So my vertical transformation is outside of the absolute value bars. Conversely, I look at my horizontal transformations. For my horizontal transformations, I can see that I am inside the absolute value bar or inside the function notation. So this time when I have a -3, I see the -3 is either inside the parentheses or inside the absolute value bar. And horizontal transformations, it kind of goes by their name, go left and right. So be careful. For horizontal transformations are opposite. So usually if you see a -3, you would think, oh, it's going to the left, towards the negatives. It's actually the opposite. It'll be going towards the positives, so right 3. Same thing, usually if you would see a positive, you would think, oh, it's going towards the positives. It's opposite, so it would go left 3. And my horizontal transformations are inside of my absolute value bars, which I can see here, or my function transformation parentheses, or function notation parentheses. Then I start talking about vertical stretches and compressions. So I see that I have a number, first off, outside my parentheses, which gives me a hint that it's vertical. So vertical is always outside of the absolute value bars. This time it's not getting added or subtracted, so I don't see a +3 or a -3 at the end. It's at the front and it's being multiplied. Now, if you're multiplying, then we're stretching by a factor of 3. If the number that is our vertical stretch or compression is larger than 1, so in case 3. If your number is between 0 and 1, such as a fraction or a decimal, that's 0 point something. In this case, it would be 0.66 repeating, or 0.3 repeating. In this case, we have a compression by a factor of 1/3. Similarly, for horizontal stretches and compressions, for horizontal, we know horizontal happens inside our absolute value bars or inside the function notation parentheses. So this time the B value is inside those parentheses. Now remember, if you're inside the parentheses, you're kind of in an alternate universe. And whatever's happening is opposite. So while you would think, oh, a fraction makes it smaller, it's actually, if it's inside the parentheses, going to give it a stretch. So we would call this a stretch by a factor of 3. And instead of 1/3, we talk about a reciprocal 3. Same idea, inside my parentheses, I'm inside an alternate universe. So 3 usually would make you think it's getting bigger. We're actually getting compression by a factor of 1/3. So the reciprocal of a 3. So be careful with these horizontal transformations, either translations or stretches and compressions. Reflection is our last one. You have to be careful about reflection. Reflection is its own transformation, which is when I have a negative either in front of my absolute value bars, in which case it's a reflection about the x-axis, or inside the parentheses, in which case it's a reflection about the y-axis. Like I said, a lot of information. We'll kind of go through bit by bit for each of it, so no need for now to memorize any of this. But this is a good reference chart to just go back as you're doing practice to look at it if you need a kind of quick way to just check, kind of like a cheat sheet. So for example 1, I see that I have my parent function f of x equals absolute value of x, and it's graphed in the grid below. So we have to draw the transformation graph. So I can see, first off, this is my parent function, and this is my transformation function. And I can see what changed from here to here is now there is a negative involved. Well, I know when there's a negative involved, there's a reflection. And so first off, this is a reflection. And since there's a reflection on the outside, I have a reflection about the x-axis. So it's not enough to just say it's a reflection. You also have to specify that we're going to reflect about the x-axis or the y-axis. In this case, it was the x-axis. The x-axis is right here. So this is my x-axis. So what it means to reflect about this x-axis is that we're going to have the same shape. So it doesn't have to be perfect. We're just doing general shapes like this. So kind of imagining if there's a mirror on the x-axis, what I see here, I will see down here. So it kind of just flips it. So that's example 1. Looking at example 2, we have our parent function, absolute value of x, and we want to see what transformation happened here. So we need to see what changed from here to here. Well, as you can see, we have the +2 on the outside, and when we have something on the outside, remember, we have a vertical translation. So this is a vertical translation. So we want to be specific about what's going on. So when we say describe, in what direction are we moving? Left, right, up, down? In this case, since it's on the outside, vertical goes up and down. And since it's positive, we are going up 2. And so in our case, this is my parent function. For my transformation function, it's just going to go to 2. And it's going to go up 2. So I'm still going to have the same graph. All that changed is that my vertex moved up 2 spaces. And in fact, every point will move up 2 spaces. So every point kind of gets shifted upwards too. And now let's talk about our new domain and range. So our original domain and range we have for our parent function. It goes forever left, forever right, 0, and upwards. So in this case, we still have arrows. So my domain is still -infinity to infinity. However, for my range, notice for my pink function, I'm no longer starting at 0. So in this case, my lowest number is 2. So it actually goes from 2 to infinity this time. I don't go any lower than 2 because it got shifted upwards. So I look at example 3. We see what's different. We still see a +2, but this time we notice, hey, there's a +2 inside the absolute value bars. So this lets me know that I have a horizontal translation. And by its name itself, horizontal means I'm moving left or right. But remember, horizontal translations are opposite. So plus would make me think go to the right, but it's opposite, so this is actually left 2. So remember, these are opposite. So my original points here, my new point will be 2 points to the left. And everything else will stay the same. The only difference is that my points are moving 2 points to the left. So this point will get moved 2 points to the left. This point will get moved 2 points to the left. So everything is just getting shifted twice. My domain and range. For my domain, I still have my arrows pointing forever left and forever right. So it's still -infinity to infinity. My range this time, notice I didn't go up or down. So for my y value, remember, range talks about y values, nothing changed from my y values. These still are at 0. So this one will still go from 0 to infinity. Now I have my parent function here. We need to see what happened here, and in this case I can notice that, hey, I'm not adding or subtracting. I have a number in front of my x. Now this is a number in front of my x outside of the parentheses, so I know I have a vertical stretch or compression. And in particular, since it's not opposite, so 2 makes you think of it getting larger, so it is stretching. So we have a vertical stretch by a factor of 2. So what do vertical stretches look like? We're not moving left, we're not moving right, or up or down. What's actually going on is it's kind of related to our slope. So originally, my slope is, let's say, up 1 over 1. Well, now that I have a vertical stretch of a factor of 2, it's going to be up 1. So still up 1, but over 2. And instead of up 1, it's going to be up 1 over 2. So be careful. This may look like, although it's not perfect, similar to my horizontal translation I just did, but notice my horizontal translation, every point moved. In particular, my vertex. But for a vertical stretch or compression, it's kind of opening out. It's kind of getting stretched out. And then for my domain and range, I still have arrows pointing left and right. In fact, you should notice my domain and range, no matter what's going on to it, will always be negative infinity to infinity because it always has double arrows. And my range will go, I haven't changed my y value, the vertex stayed the same, still 0 to infinity. So we're going to describe the transformations that are happening here. So here I notice I'm inside of the absolute value bar, so I know I have horizontal, and I'm subtracting or adding, so it's a translation. So this is a horizontal translation. And remember, it's opposite, so we're going to go right 15. Here, I see that I am adding and subtracting, so still a translation, but it's outside of my function notation parentheses, so it is a vertical translation, and it is going up 1. Since it's outside of the parentheses, it's not opposite. So plus 1 just means up 1. And then finally, I can see that I have no adding or subtracting. In fact, I'm multiplying x by 4 inside the parentheses. So inside the parentheses makes me think opposite. And so, in this case, I have, if I'm inside, I'm still horizontal. And it's opposite, so 4 makes me think stretch, but it's actually going to be a compression. And anytime you have a stretch or compression, you have to say by a factor of, and remember, since it's opposite, we're going to do the reciprocal. So instead of by a factor of 4, it's by a factor of 1/4. The last part of your notes are, hey, if I give you a graph, can you tell me what's going on here, and can you write the equation? So I know for my parent function, it starts at 0, 0. And I can see what happened is that I went 1 to the left. So one left, moving left or right, lets me know that I have a horizontal transformation, which means that when I write my equation, f of x equals, horizontal happens inside the parentheses, x plus 1. And if you need to flip back and forth to your chart at this point, that's still fine. You're just learning it so far. So remember, it's opposite when we're inside the bars, and we know we're inside the bars because we're moving left or right, which means it's a horizontal transformation. Now to check to see if we had a structure compression, I check my slope. Up 1 over 1, up 1 over 1. So my slope did not change. It still has the original slope of the parent function, which is 1 over 1. So this is the only transformation that happened. Now here, my point originally starts here, but it ends here. So let's see what's going on. I can see that it's moving right 1, 2. So it went right 2, but not only did it go right 2, it went down 1, 2, 3. So I went right 2, and down 3. I can check my stretch and my compression. Up 1 over 1, up 1 over 1, so there's no stretch or compression. So this lets me know two things are happening. Since I'm moving left or right, this is inside the parentheses because it's a horizontal transformation. And since it's going down, that means it's outside of the absolute value bars. So absolute value of x is equal to absolute value of x. Remember, it's opposite, so it's going to be minus 2. And then this down 3 lets me know that I'm going minus 3. Finally, we'll do the same thing. I started here. Now I'm here. I went up 1, 2, 3. And I went over 1. So left 1 and up 1, 2, 3. And let's check to see if I have any change in my stretch or compression. Up 1 over 1, up 1 over 1, up 1 over 1. Nope. So then I can write f of x is equal to absolute value bar of x. Opposite, so left 1 means plus 1. And up 3 is plus 3. Those are my equations. That's it for your notes for 2.1. Your practice will be in Delta Math. So make sure to go to Delta Math and look for the 2.1 practice.